Hello everyone, welcome to course study on solid mechanics. We will see a last numerical which is based on the generalized Hooke's law. Now the statement of the problem is as follows. A steel block of size 100 by 75 by 50 mm is subjected to the hydrostatic pressure of 180 MPa. Determine the change in the volume if E is equal to 210 GPa and mu is equal to 0.3. Now from the given data or from the given numerical, we can see that we have a steel block of size 100 mm, means the length of the block is 100 mm, its width is 75 mm and the depth of the block is 50 mm and is subjected to the hydrostatic pressure of 180 MPa. Now first of all we will discuss what does it mean hydrostatic pressure. To discuss the concept of hydrostatic pressure, we will consider one example. Suppose any body is immersed in any liquid, then that particular body is subjected to the hydrostatic pressure. Means all the sides of the body is subjected to the equal pressure from all the direction. Due to that hydrostatic pressure, there will be the change in its volume without any distortion in the shape. Means the body will maintain its shape as it is, but the volume will decrease under the action of hydrostatic pressure, and that hydrostatic pressure is to be considered as a compressive in nature. Therefore we will have the value of sigma x, sigma y, sigma z, which is equal to the entire value of sigma, and that value is 180 MPa, and that particular one is compressive in nature. Therefore we have the value of sigma x is same as that of the sigma y, sigma z, and entirely it will become sigma, which is equal to 180 MPa. Now we have to determine the change in the volume of the body. How to find out the change in volume of the body? We have the concept of volumetric strain. All of you know that volumetric strain is given by epsilon V is equal to change in V upon original V, means change in volume upon original volume. Once you know the value of epsilon V, we can easily find out the value of delta V. Therefore delta V is equal to epsilon V into V. But what is epsilon V? Remember that epsilon V is the strain in volume, and it is equal to the strain along x direction plus strain along y direction plus strain along z direction. So we will discuss all those things one by one. Now by using generalized Hooke's law, we have epsilon x is equal to sigma x upon E minus mu into sigma y by E minus mu into sigma z by E. Remember that those are the effect of sigma x along x direction over epsilon x, the effect of sigma y along x direction over epsilon x, and effect of sigma z along x direction over epsilon x. After superimposing all the effect of sigma x, sigma y and sigma z, we have this relation 1 upon E sigma x minus mu into sigma y minus mu into sigma z. If I put the value of E, that is 210 GPa, if I consider 210 GPa, means it is 210 into 10 raised to 3 MPa into sigma x is 180 MPa. Now it has a minus sign because that sigma x will try to compress the body under the action of hydrostatic pressure. Therefore it has a minus sign. Minus mu into sigma y. Again we have the value of sigma y minus, therefore minus minus it will become plus, and the same thing will happen with the sigma z also. On solving the equation for epsilon x, I have the value of epsilon x which is equal to minus 3.4285 into 10 raised to minus 4. So that minus sign, it indicates that the strain along x direction will be in the form of decrement into its length. So there will be the decrement along x direction. Now at the hydrostatic pressure, the value all are same, sigma x, sigma y and sigma z are same. We have same value for epsilon y also and same value for epsilon z also. Therefore epsilon v is given by, volumetric strain is given by epsilon x plus epsilon y plus epsilon z. On putting all the values of epsilon x, epsilon y and epsilon z, I have the final volumetric strain, which is equal to minus 1.028 into 10 raised to minus 3. This is the value of volumetric strain under the action of hydrostatic pressure. But we have to find out the value of change in volume by using volumetric strain, and that change in volume by using volumetric strain is given by the formula delta V is equal to epsilon V into V. Therefore, as we have already calculated the value of epsilon V, it is minus 1.028 into 10 raised to minus 3 into volume is 100 into 75 into 50. We have the change in volume is equal to minus 385.714 mm raised to cube. That minus sign, it indicates that there will be the decrement into its volume under the action of hydrostatic pressure. There will be the no distortion in the shape of the block, only there will be the decrement into the volume. Now we will stop here. In the next lecture we will discuss about the concept of member in series. Thank you.